Greetings and welcome. This is Dr. BDY Sunil, Associate Professor, Mechanical Engineering Department, Institute of Aeronautical Engineering, Hyderabad. In this session, we will be learning about the problems on time period and frequency of various pendulums. The course outcome of this topic would be compute the time period and frequencies of simple, compound and torsional pendulums using the basics of free and forced vibrations. The topic covered would be problems on time period and frequency for various pendulums. The topic learning outcome is understand the concepts of free and forced vibrations with simple harmonic motion and apply them to field problems. Let us go for the first problem. The problem given is the piston of an engine moves with simple harmonic motion. The crank rotates at 100 rpm and the stroke is 180 centimeters. Find the velocity and acceleration of the piston when it is at a distance of 60 centimeters from the center. If we draw a figure according to the given data, we can obtain this. This is the cylinder in which this piston is moving to and fro. And this piston is being connected to the crank here as shown, and this crank rotates 360 degrees with respect to point O here. And this crank pin is being connected to the piston, which makes the translatory motion possible for the piston. And according to the given data, the crank rotates at 100 rpm. That means the angular velocity is given as 100 rpm and the stroke is 180 centimeters. 180 centimeters. So 180 centimeter is nothing but the diameter. We can take it as 180 centimeter. So whatever diameter it is having, whatever diameter of this rotation having, the length of the cylinder, we can consider the movement of the piston will be that much as per the given connections, isn't it? So this is the consideration which we take, and now let us go to find the velocity and acceleration of the piston. First given data is angular speed. So the angular speed is omega is equal to 2 pi n by 60. That can be written as 2 pi into 100 by 60. So that gives the value as 10.47 radians per second. And the stroke is equal to 180 centimeters given. That means 1.8 meters. Therefore, the amplitude R can be obtained as 0.9 meters. Now, velocity of piston Vx is equal to omega under root R square minus x square. That is equal to 10.47 under root 0.9 square minus 0.6 square. That is equal to 7.02 meters per second. And the acceleration of the piston can be obtained with the formula Ax is equal to omega square x. That is equal to 10.47 square into 0.6. That can be obtained as 65.77 meters per second square. Now let us go for the next problem. A body performing simple harmonic motion has a velocity 12 meters per second when the displacement is 50 millimeters and 3 meters per second when the displacement is 100 millimeters. The displacement being measured from midpoint. Calculate the frequency and amplitude of the motion with what is the acceleration when the displacement is 75 millimeters. So we will be getting the values of x1 as 50 millimeters for the given first one is equal to 0.05 m into v. Then v1 is equal to 12 meters per second. So for first case, x1 and v1 displacement and the velocities are considered. And for second case, x2 is 100 millimeters, which will be 0.1 meters, and the velocity is given as 3 meters per second. So the velocity Vx formula is omega under root R square minus x square. So substituting the values in equation 1, we will be getting two equations as 12 is equal to omega under root R square minus 0.05 square and 3 is equal to omega under root R square minus 0.1 square. So solving the equations 2 and 3, we can get the value of amplitude R is equal to 0.1024 meters, that is equal to 102.4 millimeters, and angular velocity omega is equal to 134.28 radians per second. Calculating for frequency n is equal to 1 by t, that is equal to omega by 2 pi, that is equal to 134.28 by 2 pi, which gives the value as 21.37 cycles per second. Now coming to acceleration, when x is equal to 75 millimeters, we do have the formula as ax is equal to omega square x, that is equal to 134.28 square into 0.075, that is equal to 1352.3 meters per second square. Now let us go to the next problem. A clock with a seconds pendulum is running correct time at a place where the acceleration due to gravity is 9.81 meters per second square. Find the length of the pendulum. This clock is taken at a place where the acceleration due to gravity is 9.8 meters per second square. Find how much the clock will lose or gain in a day at that place. Now for seconds pendulum, we know that t is equal to 2 seconds. It is given that the clock is running correct at g is equal to 9.81 meters per second square. So we have t is equal to 2 pi under root L by g, which implies 2 is equal to 2 pi under root L by 9.81, which gives the value of L as 0.994 meters. Now for seconds pendulum, 1 beat for 1 second. So number of seconds per day can be calculated as 24 into 60 into 60, that is equal to 86400 seconds. Therefore, in a day, there are 86400 beats. Also, we have dg is equal to 9.8 minus 9.81, that is the difference between the acceleration to gravity. So it would be minus 0.01 meter per second square. Now dn by n is equal to dg by 2g. If we substitute the values, we will be getting dn is equal to 86400 into minus 0.01 by 2 into 9.81. So that gives minus 44.03 beats, that is seconds. So we can say that the clock will lose 44.03 seconds in a day. Now let us go for the next problem. A vertical shaft 5 mm in diameter and 1.2 meter in length has its upper end fixed to the ceiling. At the lower end, it carries a rotor of diameter 180 millimeters and weight 30 newtons. The modulus of rigidity for the material of the rotor is 0.85 into 10 power 5 Newton per millimeter square. Calculate the frequency of torsional vibrations for the system. As per the given data, d is equal to 5 millimeters, that can be written as 0.005 meters. And polar moment of inertia, that is J, is equal to pi d power 4 by 32, that is equal to 6.1359 into 10 power minus 7 meter power 4. And W is equal to 30 Newton as given. From this we can calculate mass is equal to 30 by 9.81, that is equal to 3.058 kg. And R is equal to 180 by 2, that is equal to 90 millimeters. So we can write it as 0.9 meters. 0.09 meters. And the value of I is equal to mr square by 2, that is equal to 3.058 into 0.09 square by 2, that is equal to 0.0124 kg per meter square. And G is equal to 0.85 into 10 power 5 Newton per millimeter square, that is the value given. So we can write it as 0.85 into 10 power 11 Newton per meter square. Now, if we take the time period T is equal to 2 pi under root IL by Gj, we can substitute all the values. That can be written as 2 pi under root 1.2 into 0.0124 by 0.85 into 10 power 11 into 6.136 into 10 power minus 11. If we solve this, we will be getting the value of 0.335 seconds. And the frequency can be obtained as n is equal to 1 by t. So that can be written as 1 by 0.335. So it is 2.985 cycles per second. This concludes the session. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.